Let's see the objective of the topic: to plot the graph of various conditions of a motion, to understand the nature of graph, and to calculate the physical quantities based on the graph.
Hello student, today we are going to learn the graphical representation of a motion. Now as we know, physics is an experimental science which deals with the study of large number of quantities like distance, time, velocity, acceleration, etc. Now these informations can be a complex sometime. So to make it simple, let's represent them on the graph. So let's know how to plot such a quantities on the graph. We will represent this graph by two ways. First, with the help of distance time graph, and second with the help of velocity time graph. But in this session, we are just going to learn a distance time graph. Now distance time graph is studied under the two conditions only. First, when the object is at a rest, and second, when the object is in motion, whether uniform or non-uniform. So let's study in deep.
Now let's plot the distance time graph when the object is at rest. See this graph on which we have already plotted x and y axis. Along x axis we have taken time because this x axis is always called as a time axis, and along the y axis we have taken the distance. Now let's assume that I have this ink bottle which is kept away from me for just a 2 meter away. Now after 1 second, can you say that where is the bottle? It is still at 2 meter away from me because it is at the rest, correct? So for plotting it, let's take a point where it shows a distance at 2 meter and time at 1 second. Now after this, 2 seconds are completed. Now still after 2 seconds, the ink bottle is at its own place, that is at 2 meter only. Yes or no? So we can say that after 2 seconds, the bottle is still at 2 meter away. So hence we have given a point at 2 meter as well as after 2 seconds. After each second, the bottle is still at a rest and which is 2 meter away from me. So it says that at third second, it is still at second 2 meter. At fourth second, it is still at 2 meter, and at fifth second, it is still at 5 seconds. So in this way, we have got all these points which says that this object ink is at a rest. So after plotting, we can get straight line graph. Now if you see, this graph has a nature that is a linear straight line and parallel to the x-axis. This graph represents that when the object is at rest, the nature of the graph would be straight line parallel to the x-axis. Now let's represent distance time graph for the uniform motion. Now what do you mean by uniform motion? As we know that when an object covers equal distance in equal interval of time. Now let's assume that any object is traveling 1 second per meter. So now let us see what happens and how to plot the graph. Now if the object covers 1 second in 1 meter, the first point should come over it. That says that it has covered 1 meter distance in 1 second. In the same manner, if it covers a equal distance in equal interval of time, next interval is 2 seconds and at 2 meter away. In the same manner, for the next third second, the object must be at 3 meter away. Okay. In the same manner, it would be at 4 meter away for 4 seconds. It would be 5th meter away for 5th second. So this is the graph. If we join all the points, the nature of the graph is straight line passing from the origin. Now as this graph is distance per versus time, so this actually represents a quantity that is speed. Okay. Now how to calculate the speed from this given graph? For that, let's assume that the object has started from 2 second to 4 second. Okay, let's assume this point as a and this as a B. Now from A to B, it has covered a distance of almost 2 meter. Okay, and as we know that speed is equal to distance upon time. But if we see the graphical way, we must have to plot a slope of this, and this slope says that let's assume that this point of a time is t2, this as a t1. Okay, this is the first distance, so say it as s1, and this one is second distance, so say it as s2. So the formula for slope comes is s2 minus s1 upon t2 minus t1. So this formula of a slope gives the value of speed. So in this way we can determine or calculate the quantity which is the speed from the given plot. So this is the most useful application of this distance time graph, which is representing the uniform motion of an object.
From this session, we understand that we can easily plot the distance time graph for various conditions. Second, we can identify the nature of a given graph. And third, we can easily calculate about the given quantity, that is speed is given in the uniform motion. Thank you.